Okay, now welcome to part 2. I've already got my graph completed. I've got my feasible region. Now I just have to discover that 1, 2, 3, 4 points will be utilized, after we discover them, of course, will be utilized in calculating my maximum quantity. So I can already guarantee that this ordered pair, because it was the y-intercept of line 2, guarantee that as 0, 20. This is 0, 0, bottom left. But also this point, bottom right here, is 16, 0. So hopefully you can also not just see that plotting x and y intercepts are easy to graph, so not using slope-intercept form, for example, but the intercepts. It makes it easy to graph, but it also makes it easy to see the vertices and how my next calculation will end up looking. The only ordered pair that's not as easy, just by looking at it, will be this point right here. But I can go ahead and use substitution to do that. That particular line 1 and line 2, I'll go ahead and use my either substitution or elimination approach. So these two lines right here, I'll go ahead and use whichever makes sense here. Frankly, I think elimination might be best. Taking 0.75x plus 0.5y equals 12. 0.25x plus 0.5y equals 10. What I'll go ahead and do is use elimination by multiplying this second equation simply by -1. And if I do that, that will then turn this equation, the second equation, into -0.25x minus 0.5y equals -10. So if I add these two equations up the way we see them, these are going to eliminate the y's. 0.75 minus 0.25 ends up being, again I'm adding these up, ends up being positive 0.50x, or just 0.5x, and that equals 2. We can divide both sides by 0.5 or multiply by the reciprocal of 0.5 or half, which is 2. Multiplying 2 by 2, we get 4. So the x-coordinate of this particular point here is 4. We can plug it in to find the y-coordinate. That could easily be done in either one of these two original equations. I guess I can do it right here or here before I multiply by a negative. Either way, 0.25 times 4 plus 0.5y equals 10. That then turns into 1/4 times 4, which is 1, plus 0.5y equals 10. Subtract 1 from both sides, multiply by 2, because that's again the reciprocal of 0.5. 2 times 9, 18. So the ordered pair of this point is 4, 18. Now we're not done. What we now need to do is take all 4 of these points and plug them into my objective function here. And again, if you remember the goal of this problem, it was to find the maximum number of pounds of bratwurst that can be made. So what we'll do is we'll take each one of these ordered pairs. We can almost guarantee that 0, 0 is not going to be the max, so we can almost just cross that off, frankly. But f of x comma y equals x plus y, we'll go ahead and plug in those 3 points. The first, we'll go ahead and plug in 0, 20. Which of course is 20. The second was 16, 0, I believe, that x-intercept. So 16 plus 0, of course, 16. And then lastly, 4, 18. Adding 4 plus 18, yielding 22. So we can see here very clearly that the maximum quantity is 22 pounds, and it occurs at 4, 18. If you recall, 4, the x-coordinate, represents the number of pounds of A, while 18 is the pounds of B. And that concludes section 3-4.